Welcome you all to the last session of the general track of PyCon Sri Lanka to let you know more about building a clean, maintainable, and tested code base. You will be able to grasp a lot of insights from the session and enhance your coding skills. So let me welcome Mr. Julian, who is a senior backend engineer with a passion for clean code and maintainable solutions. Currently working in the automotive industry and has previously worked within the gaming industry. So the stage is yours, Mr. Julian.
Hello, everyone. Let me share my screen. Give me a second before we kick this off. Okay. So good morning, everyone, or good afternoon over there in Sri Lanka. Actually, just to start this off a bit with a poll, how many of you have heard of Malta before? I don't think many, so let's try and answer. Show poll on stage, yes. Let's see how many of you actually heard of Malta. Oh, I'm surprised. Quite a few. Or you're just being nice.
Everyday items, tractor deliveries,
Okay, so quite a few. Well, Malta is in the Mediterranean. It's just below Italy. Let me close the poll for now. So Malta is below Italy, a tiny island of around 500,000 people at most. But I work for Heycar in the UK and in the group as well at the moment. And I'll be giving you the gist of the past 10 years in terms of clean code and how you can implement that going forward in terms of project structure, writing clean code, decoupling work, adding docstrings and tests. Although all of this is going to be a bit compressed since we only have around 35 minutes. So I'll try to give you the gist of it. And then if you have any more questions or discussion, we can take it afterwards. Let me close the poll. Okay, so let's kick this off. So basically, this is the agenda for today. It's mainly around clean code, project structure, and all of that, as we've just discussed. So I won't go into this slide. So before starting, I think it's important that we actually discuss what's clean code, what makes clean code. And it might vary from person to person in regards to the definition of clean code. To me, clean code is code that is readable, it's easy to maintain, it's tested and well documented. So if you go into a function, you expect to understand what's going on there. So let's kick this part off. Now, I guess a few of us would be a bit unhappy, maybe not unhappy, but we wouldn't really be happy about how the imports are being done over here. And we can highlight a few things that we're seeing over here that can be improved in terms of following the style guide, the Python style guide. By the way, veering off a bit, the Python style guide is usually called P8, which you can find online and you can read it and start following that as well. So a few things that we're seeing over here that can be improved. The usual imports grouping, as suggested by Python style guide, is first you would have the standard library imports, which we're seeing over here. We have a few of the standard library imports highlighted. We have the system, ABC, math, and we also have the collections. These are all standard library imports that come together with Python. So we didn't install anything to actually get these libraries. And then we have the related third-party imports, which we have a few over here. We have Django and we have the requests as well. Now, if we look at how we actually clean this up, you can see a few things have improved. You can see that at the very top, we have the standard library imports now. Also, if we go back, you can notice over here that we have multiple imports using the import keyword. This is actually discouraged. Usually, imports using the import keyword need to be on multiple lines. So the difference between the import statement at the top, and using the from keyword. The from keyword, you can actually import multiple imports, but using the import keyword, ideally, you split them up into multiple lines. So going back to where we were before, now we have the standard library imports at the top, and then we have related third-party imports, so libraries that you usually install using requirements.txt. And then further down, we also have the requests. So basically, what you can see over here is that we actually split the import keyword that we've seen before into multiple lines. We've put the collections import with the standard library imports. And then we have related third-party imports, which in this case is Django. And I also tend to like to split the third-party imports, or whatever type of imports you're importing, based on the package. So as you can see over here, the Django.database over here and the Django.conf are split out a bit. This helps with readability and also tends to, going forward, make it easier for you to understand what's going on. And then we have from requests. This is another third-party import, although I couldn't fit more imports over here, but you can have, after that, the application import. So imports from your current project, what you're using over here. Okay, so just a bit of recap over here. The usual structure is standard library imports, third-party related imports, and then your application imports. Now we can jump onto the next slide, which is around logic. So what we'll be doing over here is mainly taking this function and refactoring it in a way that's clean and something that's maintainable and readable. And basically, we'll be doing that through identifying a few things in the code that we're seeing over here that can be improved. Some of you might notice already a few things. We have no idea as of right now in terms of what the items are. We have no idea what we're updating really in the function name. The for loop is a bit vague as well. And we have no idea in regards to the execution or anything like that over here. We have a bit of duplication down at the very bottom in terms of the exceptions. So we'll try to target these issues, and going along, we'll see how we can take this and build it into something that is clean and maintainable. So the first thing that I've done over here is I've renamed the variable names and the function name. You can see that now we know that we're updating the task execution status. We know that these are tasks, even though right now we don't really know the type of the tasks. We don't know if it's a list of strings, a list of a model. And then we know that we're getting a response down here. And so far, we fixed the variable names. Then we can look at code grouping. Code grouping is, many people might call it differently, but code grouping for me is logically grouping your code in terms of purpose. So if you go back, you can see that everything is cramped together in terms of the code. And over here, we've separated the code in terms of getting the response. So logically, we're getting the response over here, and then we're doing something with the response further down, which helps a bit with readability in terms of someone being onboarded and trying to understand the code. This is much easier to understand already rather than the first initial version that we were seeing. So we've mentioned that we don't understand what the task is over here being passed to the function. So we've added type hinting. So type hinting is a way to help others understand what we're utilizing in terms of variables. And what we're seeing over here is now we understand that we have a list of tasks. In this case, they're Django models. And then further down, we've also added the type hint in terms of the variable down here. Now we understand that the response over here is a dict. So further down, we can understand what's going on in terms of even the check that's being done. We can understand that, hey, a status in this dict, and we can do certain things that we're going to see a bit further down in the next 2 or 3 slides in terms of looking for the key or handling key errors for this particular example over here. Okay, so now we're talking, right? We have a pretty good piece of code over here now. We can see that we have type hinting at the top, we have proper variable names, and we also have docstrings. So let me see if I have some highlighting. I don't have highlighting over here, but docstring is this part over here, the documentation added to the function. And there are many different formats in terms of how you write docstrings in Python. This particular example is Sphinx. It's called Sphinx. There's also Google and some other examples as well that you can follow. Although what we're seeing over here is quite self-explanatory. Let's go through it. We have usually the description at the top, and then we have the parameters. So we're saying that we have a parameter called tasks, and then we have a bit of a description of what that is. And then we also have the type underneath that, just to tell us what's going on. And since we don't have a return type, we didn't add anything else over here. The docstrings can be quite vast in terms of the specification of what you can add over here. You can also add doc tests. So tests for this function added in the documentation that we will see actually further on, almost at the end of the presentation. But going back to this is now making more sense for us, and we're understanding what's going on. So one thing that we're seeing over here is we still have quite coupled logic over here in this function. We're actually updating the task. We're also calling the step functions in AWS to get the response. So this function at the moment is doing more than just one thing. And what we don't want is we don't want to take this code and repeat it in multiple functions in order to get an execution information from the step functions. So what we're going to do is we're going to take this part out in terms of calling the step functions in AWS and the exception handling. By the way, I sneaked this in. I'm not sure how many of you noticed, but I've actually grouped the exception handling into one to reduce the duplication of the code. And basically, this is all there is to it. I've just taken that part out and put it in its own function. And basically, this function takes an execution ARN, which is just an identification for a resource in AWS, and we know that it returns a dict. So looking at this function over here, we pretty much know everything that happens here. We have a good description, we have good documentation, we have type hinting of what it expects. It expects a string as an argument, it returns a dict. In the case where this wouldn't always return a dict, you would add optional around this. We can discuss that further in the chat and in the questions going forward. So going back to the original, well, not original, but to the original function that we were doing, but cleaned up, how can we continue cleaning this up into something that's maintainable and makes more sense? So this is what we ended up with. When we took out the execution call into its own function, now we have something that's clean. The exception handling is carried out in its own function, and we have the code grouping as well. We have the documentation, we have type hinting. This is pretty much something I'd be happy with. I hope you as well. Okay. So in the next slide, we're going to discuss this part down here. So the checking if the status is in the dict is being done explicitly over here. This is, I would say, the most common way of doing it, or the most common way you'd see people doing it. Although there are two ways to do this, and those are called look before you leap versus easier to ask for forgiveness than permission. There is no right or wrong over here, really. It's just depending on the use case and what you prefer, more or less. So look before you leap is what we've done in the previous slide. And that's basically checking if a key exists before you actually do the logic or before you use that key. And the other way is to, let me take a sip real quick. The other way is to actually have that logic being done explicitly in terms of just trying to access that key without actually doing the check before, but rather wrapping it in a try catch block. In this case, it's try except. But what we're doing over here is, rather than doing the check before, we're not doing the check, but we're accepting that it might raise a key error. And then if it raises a key error, we don't do anything with it because we cannot access that key, and we print something if not. So that's pretty much it in terms of logic and the code itself. I'm going to try and use the 10 minutes or so that we have left to try and go into the project structure and a bit of testing. This is quite interesting in a way because it's usually something that not much put attention to in terms of the project structure. But in my eyes, at least from the past 10 years or so, I can say with confidence that the project structure defines if something is going to fail or not. It's something simple, but it's very, very important to give attention to how you structure your project. The example that we're going to be seeing over here is Django, so a simple Django application. And I'm going to highlight a few things and bring these up over here so we can see the difference. So if we look at the left-hand side, we can see that we have few modules, right? We have admin modules, serializers, and views, which is usually what you'd find in a Django application. But what's the issue with that? The issue with that is that if you're growing the code base, you're going to end up with few modules, but a lot of code. So once you go into the models.py, you're going to end up with quite a bit of code. Whilst on the right-hand side, what we're seeing is we have more packages, more modules, but it's much easier to maneuver and understand where things are, especially if you're adding a new model. It's easy and it makes things a bit clearer for someone that's looking at this. But one thing to keep in mind over here is the right-hand side might introduce some circular dependencies. Circular dependencies are just, imagine having two modules. Module 1 imports from module 2, and module 2 wants to import from module 1, and you end up with a circular dependency. So it depends on the use case. There's no real sort of right or wrong here. You need to be aware of the current state of the project and reevaluate if this should be split down into multiple modules or not. More information on how to split the models.py into multiple modules can be found on Django, or we can discuss it afterwards. But this is supported by Django, and it's actually promoted when you have large projects, which usually projects do end up being large, I hope. Unless they die off, it's usually the case. So let's jump a bit into tests. We're not going to go deep into tests. It's just a way of giving you a bit of an introduction into pytest, mocking, and doc tests. So let's kick that off. So what are doc tests? So doc tests are basically what's highlighted over there. It's basically the three greater than arrows, followed by the function call, and then that's the input, and then you have the output underneath it. So this is basically what will be run, executed, and then this is the expected output. Why is this something included in a talk about clean code? Is basically, imagine you're editing this function. This function is fairly simple, but if you have a function that is a bit complex, might have multiple edge cases, it might be helpful. Well, for me, it is helpful every day almost when I come across something like this. If you're making a change to the function, you can literally just right-click in PyCharm or in the IDE that you're using, and you can say run doc test, and instantly you can see that something is failing. Or you can add more cases into the doc test in order to understand or to cover actually the edge case that you've added. You can also catch certain exceptions, and you can use the ellipsis to actually do that. This doesn't specifically, it doesn't actually make using unit tests or pytest something redundant. This is something alongside it. It's a nice to have. I wouldn't recommend you trying to do an entire project using doc tests. This is more something like you have a function that's complex, you know that you can use doc tests for it, and you just opt to have that there. So over here, we're going to dive a bit into pytest, just to give you a bit of a taste in regards to pytest and one of the few cool features that it has in terms of using it in comparison to unit test. So what we're seeing over here is two things. We're seeing a decorator at the bottom, and we're seeing a variable with a list of tuples. And the tuples, we have the numbers, the input, and we have the output, the expected output on the right-hand side. So every tuple is 2 arguments, right? Which will be passed in this order. So we're telling pytest, hey, the first index in the tuple is numbers. The second one is expected output. Now, what happens over here, the main idea behind parameterize, what we're seeing down here, is to reduce duplication. So rather than writing all these test cases in the function down here, we're actually just doing a list of input-output, and then PyTest does that loop for us, and it injects those arguments in their respective function arguments down here. So if for example, we take the first case, 6x12 will be injected into numbers, and 1, 1, 2, the ratio will be injected into expected output over here. And then we just assert, this is interchangeable with assert equal and unit test. It's the same thing. It's just a Pythonic way of asserting that this is equal to that one. The last few slides, this in particular is quite interesting. And it's a tiny introduction into mocking. And what we're seeing over here is a function that is calling something that is not deterministic. Something that's deterministic is something that you give it an input and you always get the same output. That is something deterministic, something you can determine. And this is on the opposite side of things. It's something that's random, and basically it's something that we would want to mock because it's not deterministic. So basically those two functions, and then we have the mocker. So interesting over here, where does the mocker come from? Because we're not passing in mocker from anywhere. So mocker is something that I've installed. The package is called pytest mock, and basically it's a wrapper around unit test mock. It's the same thing, and it's a fixture in pytest. So fixtures in pytest are injected like magic inside your tests. So when I actually added mocker over here, pytest knows that it should grab mocker fixture and inject it over here. You can read a bit more on fixtures, of course, and pytest. We don't have the leisure of going through all of the information in regards to pytest, but it's quite interesting if this actually gained a bit of interest from you to actually go and look around in terms of fixtures and parameterize and all of that comes with pytest. So let's continue on this. So now we know that mocker is more or less unit test mock, and what we're doing here is we're just telling it that, hey, mocker.patch, I want to patch this particular function. And then underneath, we're saying the return value should be test key. And the idea of doing that is basically to cut off that undeterministic part and actually be able to test this function over here. Without this, it would be, I would say, impossible to test it properly unless you actually mock generate key over here. So that's what we've done. Now, generate key here should always return test key. And if we look further down, before jumping onto the last line, we're just asserting over here that my function, when I call my function over here, it's actually returning my key is test key. So far we know that our function over here, my function, is working as it should. We're not testing something else in the unit test. We only care about my function, and that's a unit test, right? It's testing one unit of logic. And then at the very end over here, this is usually skipped actually by a lot of people, but it's something quite powerful. With a mock, when you mock something, you can actually assert on it, on the mock itself. And that can be done by something like a third called once with. You can have a third called with multiple calls. There are plenty of methods that you can use with mocks. And basically over here, we further tested the function, my function, that it's doing the right thing in terms of calling generate key with the right argument as well. So that's that. The last slide that we're going to go through follows up on the package structure that we've seen before. So let me bring things up so you can visualize what the comparison between these two package structures. On the left-hand side, we have basically what we started with on the package structure. We have the test model 1 and test model 2. And if we want to make this a bit worse, we might have started with test models, actually, and have the testing of all the models over there, which is painful, really, really painful to work with. But this is really not that bad in terms of how it's structured. It's just testing multiple modules in multiple test modules. But the idea of making it a bit more readable is to actually try and mirror the application itself. So if you look on the right-hand side, you can see that one, we split into unit tests to give us the availability going forward to actually add another package for functional tests. I won't go into functional tests per se, but that gives you that option going forward. And also, we're mirroring the project structure over here. So we know we're testing app, which mirrors app up here. We know that we're testing the models, which is testing the models over here. And then we have each module being tested properly underneath that. Now, there's no right or wrong over here, really. Some people, the tests actually are in the package itself. So you might see that happen a few times as well, where the tests are underneath the package itself, and you'd have the test here, the test here, the test here, and so on and so forth. That's also something acceptable within the Python community. So it depends on your preference, really. Closing this off, because we don't have much time, a few tools that you might be interested in. There's Flake8, which is a style guide enforcer. There's Black, which is a code formatter. MyPy, a static type checker, which goes along the type hinting that we've seen in order to make sure sort of, hey, you're expecting a string, but you're passing a list instead. And that's something, a tool that actually highlights that. And pytest mock is what I've used in order to use the mocker fixture in my tests. So to close things off, I think most of the gist of the presentation is around giving attention to clean code. And the same way when we write in our language, such as English, we don't just write something and that's it. That's our draft. We reread it and we improve on it. And that should be done as well with code. So when you write your solution, that is not your end solution. That is the draft, and you should take that and actually improve on it and actually turn that into your solution. I hope most of you enjoyed the talk. If you need any help or want to discuss something after the presentation, feel free. We're also hiring. So if you want to nudge me or anyone in the team, feel free. Thank you.
Yes, sir. Thank you for the insight. It was really interesting and worthy for the Python community. So the delegates can now raise the questions in the Q&A chat. Yes, we already have some questions. I hope I can direct them to you. Yes. Shall I move on to the first questions?
Sure.
Yes, how to balance efficient versus clean code.
Oh, good question. I think it comes to experience. It's not easy. It's not an easy thing to do. I found it difficult myself when I started off the career. It tends to, it's different from one company to the other. If you're being pressed to deliver, you might cut corners. I cut corners sometimes as well, even though I'm experienced. But certain things you should be able to identify as this is going to give me an issue further down the line. And if it's something that is going to come back and bite you, then it should be something that you raise with your PM or whoever is leading you to actually improve on what you've done. So I would say it comes down to the person itself when you're trying to reach a balance between being efficient and writing clean code. Sometimes it makes sense to skip writing docstrings. Sometimes it doesn't, So it depends on your deadline as well.
Yes, thank you. For the next question, we have what I have learned is a clean code includes comments where necessary, good indentations, etc. Are the use of assertions and exception handling also a part of clean code? And a small addition from my side as well, like as what is the importance of comments also, if you can mention.
Sure. So I'm going to take comments over here as including docstrings, right? Yes, clean code is something that is well documented, readable. You can go in and do work on it, right? Assertions and exception handling are important, not particularly for clean code, but for code that is robust, right? You don't want your code to fall apart. So it's important to understand the exceptions that might arise from what you're writing. And then you'd need to actually write code in a way that you can handle those exceptions properly. Assertions per se, I never use assertions in my code. I do the assertions in the tests themselves. There are cases where you see in packages or libraries where you see a check being done with an assertion. So assert X equals Y, whatever. So my answer, too long to read, is there are two different things. Clean code is readability and maintainability. Exception handling and assertions are robust code, making sure your code is of good quality.
Yes, thank you. And we can move on to the next question. Is PEP 8 Python enhancement proposal useful in terms of writing clean, manageable, and tested code?
Oh, yeah, yes. It's everything that's clean code in Python. It sets the rules in terms of how we write code, and it's the backbone of how Python is written today. So it's important that if you want to be someone who sort of spends a few years writing Python, hopefully more than a few years, you need to be aware of what PEP8 suggests in terms of how you do imports, multiple line imports, if statements, and all of that. I cannot hear you. You're on mute.
Sorry. Yeah, we can move on to the next question. With a dynamically typed language like Python, there are more chances to get errors when program expanding. So how can we avoid them?
It's a difficult question to answer because this comes down to actually the gist of this entire presentation. If you write code that has type hinting and has documentation and has proper tests, it's unlikely that you'd come across a lot of errors. But you can go the extra mile and even implement MyPy on your project, which helps identify certain bugs where you'd expect to pass a string, but you're passing in a list. And that is done when in your CI or so. CI is just the process of you deploying and you run certain checks. So I think one way is to have MyPy check your project when you push on GitHub or something similar, which might help.
Yes, thank you. And there's another question like, is type hinting as same as error handling? And there's another one like, how to add type hinting as well?
Not really. Type hinting is just, it's not the same as other languages where you specify the type, and if the type passed is not the same type, you're going to end up with an error from the language itself. It's totally just for readability at the moment in Python. But having said that, you also have MyPy, again, that does the error handling in terms of the types. So in order to do that, you would need to look at MyPy to run through your project and actually identify areas where you're using a library that has type hinting. The library expects a list, but you're passing it a string. And MyPy would say, hey, you pass a string here instead of a list. What's going on? And that's something that you can use going forward to try and implement error handling for type hinting. But they're not the same, no.
Yes, thank you. And what is the best way when programming in Python? Is it functional or double RP?
There is no right or wrong over here, really. It depends on what you're building. If you have a utility function, there's no real use in taking that and putting it in a class, in my opinion. That goes in utils, and you have multiple functions that you reuse. But if you have something a bit more complex, where you have state, then object-oriented programming is where you want to go.
Yes, thank you. And the next question is there a benefit for prioritizing import modules?
I'm not sure I understand the question 100%, but I would take it that prioritizing import modules when you're building something, not really. There's no real priority for the import modules. The priority comes when they start growing, right? Most IDEs now do format your imports, so you don't really have to prioritize doing that. But you need to be aware, of course, of how we should structure the import modules. So that's the important part of it, that you understand what's going on at the very top of your module that you're using.
Yes, and we have another question like, does it gain more testable way module-based architecture rather than monolithic?
Sorry, I'm rereading that. I'm not sure I understand the question. Does it gain more testable way module-based architecture rather than monolithic? I would guess this is around having multiple modules rather than a monolith. But in terms of splitting this down into services, yes, I wouldn't say it's easier to test, but it is a bit more testable in terms of splitting things down into smaller pieces. It tends to be easier to maintain and to test. I'm not sure I answered your question, though. That's just what I've taken from the question itself.
Yes, and the last couple of questions like, how can I test a code that interact with external API?
This is a very good question. There's a cool library from Sentry. It's called Responses. So get Sentry/responses. It's a very, very cool library in terms of telling it, hey, I'm going to try and interact with this URL. And then you tell it to return something in particular, this status code and this response. And then you can also do certain things like hooks with that mock, and then you can do certain complex things further down the line. but you should check out responses by Sentry. It's quite nice.
Yes, and another one, is it better to maintain a different repository for main testing modules?
Honestly, I don't think I've ever seen it done in Python, personally, and I have never done it myself. I usually tend to like to have the tests alongside the code, so you can see how things are being done. And moving the tests out into a different repository for testing might be a bit complex in terms of how you're going to test the logic. So I would say it makes things complex and overcomplicates things, so it's best to keep the logic and the test together, more or less. It depends on what type of testing you're doing as well, if it's contract testing or something else. End-to-end testing can be done in its own repository, but unit tests per se needs to be done next to the logic.
Yes, thank you. And with the time being, this will be the last question that we'll be answering. Is there any tools we could use to help generate project structure when initializing new project?
I've never used a particular tool to generate a project structure, but even if you have a way to generate the project structure, I don't think it's going to be per se perfect. So I think you need to be cautious and give attention to detail when you're building something. The foundation of your project is really determining how you're going to end up in a few months' time, So give a lot of importance to your first few initial weeks, and remember that time you're taking now is less than the time you would take in the future to rebuild the entire project. So it's important to speak up and try to gain time with your managers or so, to have a bit of time in terms of building it properly to start off with, which would take a bit more time, but in the long run you wouldn't fail and need to start from the beginning, So yeah, it's important to push a bit in terms of writing proper code. Is that all?
Yes, we have a raise hand question in case if you're okay with it to answer.
Sure.
Yes, I'll be handing the mic to Jason. You can ask your question now.
Yeah. Hi, Julian. So I enjoyed the part of the project structure. Actually, that was the first problem I had when writing a Django application where my code is going to go into. One thing I noticed is this idea of applications where you can break down the Django application to multiple smaller applications and link them together. So my question is, at what level would you recommend breaking down? Like I've seen other platforms where you try to break down the service layers and the repository layers and the REST interactions, the things like that. So what kind of a thing does Django have in mind when they introduce this application structure?
Something I usually follow. I don't like to split things up into a lot of apps for a simple reason. If something is coupled to something else, it should be together. Then I won't split it out. It's as simple as that for me. For example, say you have an app for vehicles, right? In our case, because we work with vehicles. If you have models or makes, I'm not going to split that out into its own app. It doesn't really make sense because they're coupled together. For me, that should sit in the same application. But if it's, for example, an integration to a third party, that is something that I will take and split out into its own application. So it comes down to identifying where you should break things, and that can only be done if you're pausing a bit when you're working and saying, okay, this doesn't really make sense to be with a vehicle, I should move this into its own application. But even moving things in their own application, at Haker we have around 8-9 applications, I think, in our Django project, which we're splitting down into microservices at the moment. But basically, they still grow quite a bit. Even in the vehicle app itself, we still have multiple models that can go into the hundreds of lines of code, So I think it's important to also have the idea of splitting it down into modules, which help a lot, because then you can write things a bit cleaner, and they are a bit more readable as well in terms of, I sometimes go into an app, Jason, and honestly, I go into the models and I have to use the find in order to find the model itself, which is not a good indication, right?
Yeah. Thank you, Julian. Yeah, that was clear.
Okay. You're welcome.
Yes, thank you, Mr. Julian, for sharing your knowledge with this Python enthusiast. And thank you to all the active delegates for getting the maximum out of all of the sessions of the day. So finally, we have the last keynote speech from 5 p.m. onwards, which will be the gist of the discussions on the day: what was, what is, and what will Python be in the future. Hope that would complete your learnings today with a sneak peek of the future of Python as well. Hope you would not miss that insightful session as well. So see you all in the final keynote space. Thank you.
Thank you. Bye-bye.